They're being recorded. All right, so let's start the question asking. I'm going to need to stop at about 8:25 because I have an advanced math trig session that I'm doing at 8:30, and I need to record or post our recording after we finish. So please start asking questions so I can start answering them. Okay, let's see, page 180. This is a chapter 5 question. Number 5. Okay, so page 180, number 5, and the directions say, tell what number must be added to complete the square. So that is creating a perfect square trinomial, and they gave you x squared plus 20x plus blank. And so because the leading coefficient is a 1, you take half of this 20, half of that is 10, and then you square it. So you want to add 100. Okay, now when we were in chapter 5, you hadn't done factoring yet, but now that you've done factoring, I can tell you that completing the square is specifically to create a perfect square trinomial. And so if you were going to factor that, now that would become the square of a binomial, and your binomial would be x plus 10. And you get that binomial by taking the square root of the x squared, the square root of the 100, that gives you your x and your 10, and then the sign of the middle term right there. So x plus 10, the quantity squared. Okay, all right, Tara, there you go. Oh, you guys are not asking very many questions. Okay, let's keep the questions going, okay, so I can just keep answering. Okay, Ella has a question on page 379. Number 5. All right. Ella, double check your page. You said 379. There aren't any questions on 379. 381 is the closest to that, and it's solving an equation by factoring. Is that the question you're asking? Oh, 376. Okay, thank you. Okay, there we go. All right, page 376, and then number 5. All right, so this says find the values of x, which must be excluded from the domain, then tell which feature, an asymptote or removable discontinuity there will be at each of the excluded values, and then draw the graph. Okay, so we have a function f of x given to us. It is not factored. It says x squared minus 4x plus 3. And then the denominator is x squared minus x minus 6. All right, so I'm going to factor both the numerator and the denominator. So my numerator factors into x minus 3 and x minus 1. My denominator factors into x minus 3 and x plus 2. So my x minus 3's cancel. By the way, in that factored denominator, I'm going to get two excluded values. X cannot equal 3 or negative 2. Okay, so those are my excluded values, and then I'm going to tell which feature will happen at each one. At x does not equal 3, that's going to be a removable discontinuity. I'm just going to put RD for removable discontinuity. And then at negative 2, I'm going to have a vertical asymptote. And the difference between those two, even though they both had factors in the denominator, the x minus 3 factors got canceled or removed. And so when I say removed, it makes me realize, oh yeah, that's removable discontinuity. All right, so here is my simplified fraction that I'm boxing in red. Okay, and so I'm going to start my graph. Let's use that pretty purple I had earlier. Okay, so I'm going to start with my vertical asymptote at x equals negative 2. Okay, so there's my line x equals negative 2. By the way, the numerator tells me, if there's a variable expression still there, what the x-intercepts will be. And so since there is one variable expression there, x minus 1, I know at x equals 1, I will have an x-intercept. Okay, so now I'm going to use my vertical asymptote to give me hints as to what x's I should plug in. So let's say I'm going to do at least 3 points to the left of that vertical asymptote. So that was at -2, so 3, 4, 5. So I'm going to do -5, -4, and -3. Then I'm going to draw a line because I'm going to skip -2. Then I'll do -1, 0. I'll skip 1 because I already know it's an x-intercept. And then I'll do 2. And I wanted to squeeze in 3, but actually what I'm going to do is I'm going to write it right here, and I'm going to put 3 and put an open circle right on my XY table to remind me that I'm going to have an open circle there. Okay, open circle at 3, because remember, that's my removable discontinuity. Okay, so now I'm ready to start plugging in. So in the numerator, when I plug in a -5, I get -6, and denominator -3, so -6 over -3 is +2. Okay, I plug in a -4, and I will get -5 over -2, that's +2.5. All right, it's a mixed number. And then -3, I get -4 over -1, that's +4. Okay, I'm going to start plotting those. 1, 2, 3, 4. Okay, -5 was at 2. -4 was at 2.5. And then -3 was at 4. Okay, so I can see from these points that my graph is going to approach the vertical asymptote that I have right there. And then I would say that it's probably a little questionable what the bottom part of this, or going to the left, would approach. It's going to approach a horizontal asymptote of y equals 1. And your book doesn't really go into horizontal asymptotes very much, but if you plugged in, let's say, -10 and then -20, you would realize that it's going to give you like 1.01 or something like that, really close to 1, but it'll never go below y equals 1. Okay, so you would have to plug in some more points to be able to truly discover that. Okay, when I plug in -1, I'll get -2 in the numerator, +1 in the denominator, so that equals -2. Plugging in 0, I get -1/2. And then plugging in 2, I get +1/4. Okay. All right, so let me put on the y-axis to -2. All right, I have -1, -2. I have 0, -1/2. We have that x-intercept at 1. And then at 2, I have +1/4. And so my graph is going to approach that horizontal asymptote. And again, if you didn't realize that you had a horizontal asymptote right there, you would discover it if you plugged in, say, +10 or +20, okay, to get more points. And oops, I forgot to do my 3. Let's plug in 3. I get 2 in the numerator, so 2 over 5. And so right here, I'm going to put it in red so it stands out. There would be a hole in this graph right here. Okay, and so that is your removable discontinuity, RD, at 3, 2/5. Okay, all right, there you go. Okay, now we've got some questions. All right, Josh has a question on page 421, number 33. Okay, they are asking us to simplify. The directions say transform the given expression to simplest radical form. And so we have the square root of 3 minus 1 over the square root of 2 minus 1. Okay, so I have a radical in the denominator, but there are 2 terms. And so we've learned that in order to get rid of the radical in the denominator, you have to multiply by its conjugate. So I'm going to multiply by the square root of 2 plus 1, and then over itself, so square root of 2 plus 1 in both the numerator and denominator. Okay, in the denominator, let's start with that. My square root of 2 times square root of 2 is 2. my outers and inners are going to cancel, and I get 2 minus 1. So I actually just have a 1 in my denominator, and so we won't even end up with a fraction. Okay, in the numerator, my rad 3 times rad 2 is rad 6. Then I get plus rad 3 minus rad 2 minus 1. And none of those terms simplify or combine. They are not like terms. And so I just have rad 6 plus rad 3 minus rad 2 minus 1. And that is my final answer. Okay, and I have no denominator at all because it was all over 1. Okay, there you go, Josh. All right, Tara, page 406, R4D. Excuse me. Okay, page 406, number R4D. All right, they gave you 9 minus p squared plus 8p minus 16. All right, so as soon as I see 4 terms, I know I'm going to group. And when you have 4 terms that you're going to group, you want to look for either 3 and 1 or 1 and 3 first. So I'm going to underline the last 3 terms there. If I ignore my signs, do you guys agree that p squared is a perfect square? 16 is a perfect square. I'm ignoring the signs. Okay, and if I take the square roots of both of those terms, the square root of p squared is p, the square root of 16 is 4, the product is 4p, and if I double it, I get 8p. So whenever the 3 terms that are going to be a perfect square trinomial are at the tail end of your 4 terms, you have to factor out a negative out of just those 3 terms. Okay, so I've written down my 9, my minus sign, and now I'm factoring out that negative 1. So in the parentheses, I get p squared minus 8p plus 16. So now look what's in my parentheses. That is a perfect square trinomial, and it factors into the square of a binomial, like we talked about on our first example. So that perfect square trinomial factors into p minus 4, the quantity squared. And then since I have this 9 minus in front of that, I've now gone from 4 terms down to 2 terms, and my 2 terms are a difference of 2 perfect squares. And so I'm going to factor that into the sum and the difference of their square roots. So the square root of 9 is 3, so I write 3 here and 3 here. And then the square root of p minus 4, the quantity squared, is p minus 4. Well, after this plus sign, I can just write p minus 4. But after the minus sign, I have to put in parentheses p minus 4 and then distribute that negative. Okay, so let's just write that second factor there. I have 3 minus p and then plus 4. Well, this 3 and negative 4 in the first factor and the 3 and the positive 4 in the second quantity, those are like terms. So I want to simplify this. So I think I'm going to write p first and then minus 1. And then here I think I'm going to write 7 minus p. And that is my final answer. It is 1 term, and every factor is completely factored and simplified. Okay. All right. Now this could have been factored a different way or solved a different way. It's not solving, I shouldn't say that. Gone about a different way, because from the very beginning, if anybody combined that 9 with that negative 16, they are like terms, so you certainly could have. Then you would have had a quadratic trinomial that would then factor into this. Okay? All right, but I'm showing you how the grouping of 4 terms works when you have a perfect square trinomial. Okay, so that's how I did it. Okay. All right, Phoebe, can I do an example of the long way of augmented matrices? The long way. I'm assuming, Phoebe, that you mean a 3 by 3 using augmented matrices. I'm not exactly sure what you mean by the long way. All right, I'll wait for you to answer that. Meanwhile, I'll do Dylan's question. All right, page 360, number 7. All right, page 360. number 7. Okay, this is asking us to carry out the indicated multiplication or division. All right, so we have x squared plus 4x plus 3 all over 5x, and that is being divided by x plus 1 over x plus 5. All right, so I'm going to I'm going to factor my numerator of the first fraction. Okay, so I have an x plus 3 times an x plus 1. Okay, then I have 5x in the denominator here. And then next what I want to do is instead of that division sign, I'm going to change that to a multiplication sign. And so dividing by this fraction is the same as multiplying by its reciprocal. So I get x plus 5 over x plus 1. So the quantity x plus 1 here in the denominator is going to cancel with the factor x plus 1 in the numerator. And then this is kind of a dissatisfying answer, I think, because that's all that cancels. So I get x plus 3 times the quantity x plus 5. That's what's left in the numerator. And then my denominator is a 5x. And that's your final answer. That's all you can do. Okay? All right. All right, back to Phoebe's question. The higher order system. Higher order. Okay, so yeah, you mean 3 by 3. All right. And let me, not giving me a page number. I believe that's chapter 4. Yes, it is. Augmented matrices. Here we go. Okay, section 4.8. 4.6. It has nice answers. Okay. I think I'm just going to go through till we find Z. Okay, that's all we did on our test. So I think that's a good place to stop. All right, so on page, I guess technically it's not one. Well, I am getting it from page 141, but I'm going to do it by augmented matrices. Okay, so number 2 is where my system is coming from. All right, so they gave me 2x minus y minus z equals 7. Then second equation is 3x plus 5y plus z equals negative 10. And then third equation is 4x minus 3y plus 2z equals 4. Okay, so this is kind of difficult to do on this because I don't have a lot of room horizontally. Okay, so here's my x column. I'm going to go down each column. So 2, 3, 4, that's my x column. My y column is negative 1, positive 5, negative 3. And my z column is negative 1, positive 1, positive 2. And then here's the augmented portion of my matrix, 7, negative 10, and 4. Okay, my first goal is to get a 0 right here. First column, second row. So I'm going to put my arrow across from that second row because that's what I'm trying to change. Okay, and I think I'm going to use row 1. I'm going to multiply it by negative 3 and add that to row 2, which I'm going to multiply by positive 2. Okay, so let me do the result of that in black. So I'm only using row 1 to help me get my 0 in row 2. Okay, so 2 times negative 3 is negative 6. 3 times positive 2 is positive 6, and when I add those, I get the 0 I was hoping for. Okay, then the next step is going to be for the y columns. I'm going to get a positive 3 times, plus a positive 10, and so that is 13. And then I'm going to get positive 3 plus 2 is 5. And then for the augmented part, I'm going to get negative 21 plus a negative 20, so I get negative 41. Okay, that was step 1. Step 2, let me do this in green, I guess. I'm going to put my arrow across from the third row because now my next step is to try to get a 0 instead of that 4. Okay, so I'm going to take row 1, multiply it by negative 2, and then add that to row 3. And I don't need to multiply row 3 by anything. So I get negative 4 plus 4 is 0, and I get the 0 I wanted. That's going to be positive 2 plus a negative 3, that's negative 1. Positive 2 plus 2 is 4. And then negative 14 plus 4 is negative 10. Okay, my next goal is to get let's do the pretty purple. I want to get a 0 right here instead of that 1. Okay, so I'm going to go arrow from here, and I'm going to go all the way to here. Okay, so I want to take row 2, multiply it by, actually, I'm not going to multiply row 2 by anything. I'm going to add row 2 to my row 3, which I'm going to multiply by 13. So if I multiply that row 3 by 13, do you see where the negative 1 is? I'll get negative 13, and when I add 13 to it, I'll get the 0 that I want in that spot. Okay, so let me put my brackets. I'm using row 2 to help me get a 0 in row 3. Well, look at the first two parts of row 2 and row 3. They're both zeros. So if I add 0 to 0 times 13, I keep the 0, and that's exactly what I wanted to do. Okay, so row 3, I get negative 13, and when I add 13 to it, I get 0. 4 times 13 is going to be 52, plus 5 is 57. And then here's the big question. Is this going to be a multiple of 57? All right, I get negative 130. I'm going to jot that down. Negative 130. And then I need to add a negative 41. So I get negative 171. And then this is going to be my last step. 171 divided by 57. Yay, a nice neat integer. Okay, so my last step is to take this row 3 and divide it by 57. And so when I do that, I get 0, 0, 1, and then negative 3. And we're going to stop right there. I know that my z equals negative 3, and that's exactly what we asked you to stop on when we took a test on this. Okay, so we're going to stop there here too. Okay, moving to the next question. Dylan, I've already done your question. Melissa, page 382. Page 382. Number 31. Okay, 382, number 31. And they are asking us to state the domain, then solve the equation, and show the step where you discard any extraneous roots. All right, so if you are in my class, you know that I've said whenever you have or you see fractions in an equation, there's something you should do first. Let me finish writing my equation here, and then I'll say it. Okay, so do you definitely see that you have fractions in an equation? And so the first thing you should do is get rid of your denominators. Well, I'm going to do a little bit of work before I try to get rid of my denominators. First of all, I notice in that third fraction that this x squared minus 4 can be factored into x plus 2, x minus 2. Okay, so instead of that x squared minus 4, I now have that. And then I notice that my first fraction has x plus 2 in the denominator, but my second fraction has 2 minus x. Well, I see that x minus 2 is the opposite of this 2 minus x. So I'm going to cross that out and write x minus 2, but I can't just play magician and change that. Those are not equivalent, but I can change the sign right here in front of my fraction. Now it's equivalent. So I had minus 2, and then in the denominator 2 minus x. So now I have plus, and then x minus 2. So I wrote the opposite of the denominator, and then I changed the sign to the opposite. So two opposites make it the same. Okay, so now here's my big step. This is my getting rid of the denominators. I'm going to multiply every term in this whole equation by x plus 2 times the quantity x minus 2. And I'm going to distribute that to the first term, to the second term, and to the third term. Every term has to get multiplied by that. Okay, so in the first term, my x plus 2's will cancel, and so I'll have 2, the quantity x minus 2. No more fraction. Then I have a plus sign. Remember, we changed that to a plus sign. Next, my x minus 2's will cancel, so I have plus x, the quantity x plus 2, and then my equal sign. Then for my third fraction, the x plus 2 and the x minus 2 completely cancels out, and I get x squared plus 4. Okay, so now let's distribute. I get 2x minus 4, excuse me, plus x squared plus 2x equals x squared plus 4. So I notice I have an x squared on both sides. I'm going to subtract x squared on both sides, and they cancel out. Then my 2x on this left side plus this 2x, that equals 4x. And then I'm going to take this negative 4 and add it to both sides, and so I get 8. And so x equals 2 is the solution to this equation. I'm not done, though, because there's actually some things they asked me to do in the directions that I haven't done yet. So it said state the domain. Well, if you look back at the original equation, we had variables in our denominator, right? And so for my domain, let me write it here in the lower left-hand corner, I want to say that the domain is all reals, but x cannot equal 2 or negative 2. Either one of those will give me a 0 in the denominator, and that is undefined. So that's the exclusions to my domain. The domain is all real numbers, but x cannot equal plus or minus 2. Well, we just got 2 as our answer, and we just said in our domain that x cannot equal 2. So I need to reject this, and my actual answer to this problem is the empty set. There is no solution to this. That is an extraneous root. Okay? All right. That's how you do that problem. Okay, let's see, that was Melissa's question. Okay, sorry, I have to look so closely. This is kind of tiny and I'm kind of blind. Oh, that helps. Made it a little bit bigger. Okay, please hold. Okay, thank you. All right, so Gia is asking if I could explain how to do one of these. Let's look at the page and then we'll pick one. Or if they're all different, we can do all of them. All right, so page 340. And let me get there and then look at these problems. 5, 7, 17, or 25. Okay, 340. Okay, so this is all in a factoring section. So, all right, they might all be a little bit different. So I'll start with number 5. Okay, so number 5 is a cubed minus b cubed. All right, so this isn't a very complicated difference of two perfect cubes, but if you don't know the pattern for a difference of two perfect cubes, I don't care how easy it is, you won't know how to factor this. So hopefully you've memorized the pattern. This is the sing the song thing. So a difference of two perfect cubes, same as a sum of two perfect cubes, factors into the a binomial times a trinomial. So that's the first thing I want to write. So I put my parentheses so it kind of looks like a binomial times a trinomial. And then you sing the song. So you take the cube root of the first, that's A, and the cube root of the second, that's B, and you keep the same sign. Then, I'm looking at my binomial, square the first, change the sign, multiply together, add the square of the last. And so there is your answer. Okay, and that's all a matter of memorizing that pattern, because there's no way you would have guessed that that's the answer without knowing the pattern. Okay, next, number 7 is completely a different type of factoring problem, so I'll do that one also. Now the book says factor by splitting the middle term or demonstrate that the polynomial is prime. Okay, this is number 7. And it says 12, whoops. Okay, 12x squared plus 25x plus 12. All right, so I'm going to do first what's called the discriminant test, because I don't want to try to factor this if it's prime. Okay, so I'm going to go 25 squared minus 4 times 12 times 12. I'm doing b squared minus 4ac. When I do that, I get positive 49. Because that is a positive perfect square, that tells me that this is factorable. Okay, so I'm going to do my little x because these are fairly large numbers. So I'm going to multiply the 12 times 12. That's a positive 144 at the top part of my x. And then I'm going to put a plus 25 down here. Okay, so next I'm going to think to myself, what number here and here will multiply to give me a product of positive 144, but will add up to positive 25. So when I think about my signs, let me do this in red. When I think about my signs, they both need to be positive. Okay, so I happen to have done this example earlier today, and I remember, let's see, it was 6, was it 6? No, 9? Yeah, 9 and 16. Okay, so 9 times 16 is 144, and 9 plus 16 is 25. Okay, so this is my first year doing factoring this way. So I know if you have other teachers, they will split the middle term like the book implied to, and there's nothing wrong with that. I've taught that for many, many years, like decades. But I just find that students make some mistakes when they do it that way, and this is pretty easy. All right, so here's how you do this. If this is new to you, you put the 12x squared in the top left box. You put the plus 12, so the first term and the third term, in these two boxes. And then this plus 9 that I got here and the plus 16, I put it in the other two boxes. So here I'm going to write plus 9x. Of course, I have to put the x from that middle term, and then plus 16x. Okay, now what I'm looking for, and I'm going to do this in my pretty purple, I'm going to go up the first column. So the 12x squared and the 16x, I'm looking for what's in common there. Well, there's a 4 and an x in common with those two boxes. Then the second column, I'm going to go up that column, and I'm looking for what's in common. Well, there's a 3 in common. And since that top box is positive, that's a 4x plus 3. Okay? All right, now look at the top row. I'm going to go from right to left, and I'm looking for what's in common. There's a 3 and an x in common. And then the bottom row, go right to left and look for what's in common. There's a 4 in common, and since that 16x is positive, this is a plus 4. And so I believe that this is 4x plus 3 times the quantity 3x plus 4. And let's double check it. So 4x times 3x is 12x squared. That's my first term. That's perfect. This 4x times 4 is 16x plus 9x. That gives me my 25x in the middle. And then plus 12. It's perfect. Okay, so there you go for number 7. Okay, Gia, let's look at 17. Oh, you know what? Let me go back. That wasn't number 7. It was number 17. I just labeled it wrong, but I did the right one. Okay, so, I was supposed to do 7. I just did 17 first. Okay, so now let's do number 7 on that same page because that is also, well, it's actually very similar to number 5. Okay, this happens to be a sum of 2 cubes, so I'm going to sing the same song. First, I'm going to say it's a binomial times a trinomial, and now I'm going to sing the song. So you take the cube root of the first, that's y, cube root of the second, that's 4, and you keep the same sign, plus sign. Then I'm going to square the y, square the first, change the sign, minus sign, multiply together for y, add the square of the last. And there's your answer. Okay, easy if you know the song. Okay, now number 25. Let's see if that's different. It's in the same section as factor by splitting the middle term. But that's all right. It'll give us more practice in that concept. All right, so it is 36x squared minus 63x. Those are some pretty big numbers, plus 20. And for sure, the first thing I'm going to do is the discriminant test. I don't want to waste my time trying to factor this if it's prime. So I'm going to go 63 squared. Now I know my b is negative 63, but if I'm going to square it, isn't it going to become positive anyway? Okay, so 63 squared minus 4 times 36 times 20, and I get 1089. If you don't know if that's a perfect square or not, then you should go square root of answer and see if you get an integer. I do. It's 33. So that was 33 squared. So that means this is factorable. All right, again, these are pretty big numbers, but that's okay. All right, so in the top of my x, I'm going to do 36 times 20, and that's positive 720. And then in the bottom part of my x, I put negative 63. Okay, so because I want a product to be positive, and a sum to be negative, that means both of my numbers are going to be negative. So when I multiply two negatives, I get a positive, but when I add them, I get a negative. Okay, let's see. 48 times 15 is 720, and 48 plus, or negative 48 plus negative 15 is 63. All right, so negative 48, and I'm sure that would take a little bit of time. I kind of looked at the answer to save us some time right now to get those numbers. All right, so you'd have to play around until you got those numbers. I'm going to show you the box again. All right, so you put the 36x squared in the top left box, 36x squared, the plus 20 in the bottom right, and then I'm going to put negative 48x here and negative 15x there, and it doesn't matter on those two which way you go. I could have switched those two. Okay, I'm going pretty purple for my answers. So I'm going to go up the first column. Let's see, there is a 3 and an x in common there. Up the second column, and then I'm glad there are negative signs here. When I just look at my numbers, I see that there's a 4 in common, but see how the negative 48x is negative, so I'm going to put negative 4 or minus 4. Okay, top row, I'm going to look for what's in common. And there is a 12 and an x. Okay, and the 36x squared is positive, so that's positive. And then in the bottom row, I'm going right to left, there's a 5 in common, but because that 15x is negative, I'm going to put minus 5. Okay, so here's my answer. 3x minus 4 times 12x minus 5. If you've never seen those boxes before, you're probably going, hey, that's pretty nice. I agree, I really like them. Okay, I'm going to double check my answer. 3x times 12x is 36x squared. For my outers and inners, I get negative 15x and a negative 48x, and that does add up to negative 63x. And then negative 4 times negative 5 is plus 20. So there you go. Okay, I just really like that, even with pretty big numbers. Okay, let's see. Gia, I have answered all your questions. Okay, John has a question on page 453. Page 453, number R3D. Okay. All right. It says 3 over the 5th root of 3. Okay, so I'm envisioning that some of you are thinking you should multiply by the 5th root of 3 over the 5th root of 3 because you're so used to rationalizing square roots in your denominator. Well, if I multiply by the 5th root of 3, right, 5th root up here and 5th root down here, if I multiply by the 5th root of 3, do you agree that gives me the 5th root of 9? Or let me say it another way, the 5th root of 3 squared. Well, I can't take the 5th root of 3 squared. That's not a perfect power of 5. So that's what I'm looking for, is a perfect power of 5 under the radical. So here in the denominator, I'm going to write 3 to the first. Don't I need a 3 to the fourth so that when I multiply those together, I will get a 5th root of 3 to the 5th, and that's a perfect power of 5. And then I can take the 5th root of 3 to the 5th and just get 3, a nice rational denominator. Okay, so whatever I did to the denominator, I have to do the same thing in the numerator, except for I'm going to write 81 instead of 3 to the 4th. So in my numerator, I have 3 times the 5th root of 81. Let me write it here, 3 times the 5th root of 81. And then those 3's are factors, so those cancel, And my final answer is the fifth root of 81. There you go. Okay, let's see. Yep. Okay, that was John's question. Jade is asking for page 381, number 31. Oh, we already did that one. Yep, we already did that one, Jade. Okay, Andrew, can I do a 3 by 3 for Kramer's rule? I will solve for one variable. Let me see how we're doing on time. Oh, we're all right. Okay, let's see. That was chapter 4. And let me find a 3 by 3. Sure what section is linear equations with 3 or more variables. Okay. Okay, here we go. I want it from the section that has the answers so I can make sure I do one that has nice, neat integer answers. Okay, let's see. I'm going to take one that we did earlier for augmented matrices. It's on page 141, number 2. And we solve for z using augmented matrices. So why don't I just do solving for z again? We've got -3, and you'll just see the same answer, but finding it a different way. Okay, so I feel like I need to rewrite this system. So it's 2x minus y minus z equals 7, and 3x plus 5y plus z equals -10. And then we have 4x, minus 3y plus 2z equals 4. All right, so I am going to start with my denominator determinant, and I'm going to call it d. Okay, it's going to be a 3 by 3, so I'm going to have for the x column 2, 3, 4, y column -1, 5, -3, and then z column -1, 1, 2. All right, so I like to circle my top row entries and then write plus sign, minus sign, plus sign. You always add, subtract, add. Okay, so I'm going to write that this equals 2. Okay, that's a plus 2, so I can just write the 2. And then I'm going to cross out the row and the column that that 2 is in, and I'll be left with the 2 by 2 determinant, 5, -3, 1, 2. Okay, then I'm going to go minus a -1, so that becomes plus 1. And then again, I'm going to cross out the row and the column that the -1 is in, and I'll be left with 3, 4 for the x column, and then for my second column, 1, 2. And then I'm going to go plus a -1, so that's -1. And then I cross out the row in the column that that -1 is in, and I'm left with 3, 4, and 5, -3. Okay, so underneath here, I'm going to write 2 times. I'm going to do my crisscross applesauce. Evaluating a determinant, you go 5 times 2, so that's 10, minus 1 times -3. So minus a -3 becomes plus 3. Okay, then I have plus 1 times 3 times 2 is 6, minus 1 times 4 is 4. And I'll go back and evaluate those in a moment. Minus 1 times, I get -9, minus 20. Squeezing that in. Okay, this is 2 times 13. Let's just do that. It's 26. Plus 1 times 2, that's plus 2. And then minus 1 times -29 is plus 29. Let's see, I get, excuse me, 40, 55, 57. Okay, and initially that might seem like, ooh, I don't know about a 57. Did I do that right? 40. 55, 57, yeah. But when I do my n sub z, then we'll know whether we've done it correctly or not. Okay, I do want to write n sub z here. I'm solving for z on purpose so that we can compare to what we had before. Okay, and I don't want to take too much room here. All right, I'm going to leave my x column alone. It's 2, 3, 4. And my y column, leave it alone, -1, 5, -3. Now for my z column, because this is n sub z, I take these constants back to my original equations to the right of my equal sign, and that is going to become my third column, my z column. So 7, -10, 4 replaces that original z column. Okay, so let's do this pretty blue. I'm going to circle my top entries, and I'm going to go plus, minus, plus. Okay, you always go plus, minus, plus, no matter what those numbers are, positive or negative. Let's separate this a little bit. Okay, so I need to write a little bit smaller so that this can fit. All right, this is going to equal 2, and then this time I'm not going to write my augmented matrix that remains. I shouldn't say, I didn't mean augmented matrix. I'm not going to write the 2 by 2 determinant that remains when I cross out. I'm just going to go ahead and evaluate it. Okay, so it's 2 times, and then I get 20 minus 30. And you know what? I'm going to go ahead and just evaluate that while I'm on, working on it. So 2 times -10, I get -20. Okay, then I go minus a -1, so that's +1, and then cross out the column in the row that -1 is in, and I'll get 12 minus a -40, so plus 40. That ends up being +1 times 52, so that's plus 52. Okay, and the last one is going to be a +7. Cross out the row and column, and I get -9 minus 20. So that's +7 times -29. That's going to be 14 minus 203. I'm going to double check that. I don't want to make a mistake. 7 times 29, 203. Okay, so I have -203. -203 minus 20 plus 52. Oops. Plus 52, and I get, something's wrong, -20 plus 52 minus 203. Okay, I get -171. And so when I take my n sub z, which is -171, and divide it by my d, which is 57, I get, let's go, beautiful blue, z equals -3. And that's exactly what we got when we did our augmented matrices. And so you can see that we got it right. Okay, there you go. That is Kramer's rule or determinants. Okay, let's see. All right. That was 141. Who was I doing that for? Okay, that was for Andrew. All right, let's see. You guys have asked some questions since then. All right, I want to see what this questioning is. If the numbers were complementary, could you take out a GCF to make the numbers more manageable? For number 25, if the numbers were complementary. Let me go back and look for a number 25. Was that from our factoring? Do you mean if the numbers, I don't know what you mean by complementary. If the numbers were like nicer numbers? Lizzie. Okay, let's see what John said. Are there any questions where we have to use Kramer's, or could we just use augmented? John, I think it doesn't matter because it's multiple choice. Okay, so let's just talk about the logic of multiple choice questions. If they ask you to solve a system of equations and they don't tell you how to, then you can use whatever technique you want. In chapter 4, we learned how to do linear combinations. We did Kramer's rule, which is determinants, and we did augmented matrices. Any of those will solve either 2 by 2 or 3 by 3. 3 equations with 3 variables or 2 equations with 2 variables. However, I know most of you want to do linear combinations because that's what you're the most familiar with, but you certainly could have, let me move to my next empty page. Couldn't we just say, whoops, that's certainly not empty. Couldn't we just say, evaluate this determinant, okay? Nothing to do with solving a system, but if I put like 3, 5, -2, 6, and I just say solve that, well, you better know how to do determinants, right? Or I could give you a 3 by 3. Number, evaluate that, okay? So I'm just saying if you don't know how to do Kramer's rule or determinants, or you don't know how to do augmented matrices, it doesn't necessarily mean that they're going to ask you to solve a system using a specific method, because you're right, it's multiple choice. If they're only after the answer, you can use any technique you want. But if you're asked a specific question, how do you evaluate this determinant, or how do you do something with an augmented matrix, then you better know how to do it. Okay, so let me go back and see what I can get to. All right, we have about 5 minutes left till I need to go. All right, Diego, let's do your question. 279.41. 279, number 41. Okay, good old logs. Cross that off a little bit. All right, page 279, number 41. All right, they are asking us to write the expression as a single logarithm of a single argument. So this says 5 times the log base 12 of 2. Okay, so even though there is only one log here, it doesn't start out with a log. It starts out with this 5. And so I'm going to do what I call reverse whistle. Okay, that's my third property that starts with this. It says if you have log base b of x to the n, this is called log of a power because x to the n is called a power. And you take that exponent, and I call it the whistle property because that exponent goes to the front. So this is equivalent to n times log base b of x. That's your third property of logs. By the way, I have some advice for you guys. When we were in this chapter, it was chapter 6, some of you did not know your properties of logs, and we were in the chapter. So now that it's, I don't know, 2 months later, you probably don't know your properties. You better go back and make sure you know your properties of logs. There's only 3 of them, plus the definition of logarithm, which you absolutely need to know, how to switch from logarithmic form to exponential form, or the other way from exponential form to logarithmic form. Those 4 things, they're pretty easy if you know them, but if you don't, they're very difficult. Okay, so I'm going to take this 5 and bring it to the end. I'm going backwards from that property that I just wrote. So I get log base 12 of 2 to the 5th, and so I'm going to evaluate the 2 to the 5th. So I have log base 12 of 32. And there is a single log of a single argument. So that's my answer. Okay, let's see. John, page 346, number 3. Okay, this is asking us to do polynomial long division. Page 346, number 3. Okay, they wrote it as a fraction. I'm going to go ahead and write it so I'm ready to divide. So my numerator of my fraction goes inside this division symbol. So that's called my dividend. So 8x cubed plus 10x squared minus 13x minus 20. And they want us to divide that by 2x plus 3. Okay, so first I'm going to ask myself, 2x times what gives me 8x cubed? So I get 4x squared. Next I multiply, I get 8x cubed plus 12x squared, and then I'm going to switch colors. I next want to subtract, but I'm going to change the signs instead of each of these. So they're now both negative, and now I'm going to add, because subtracting is the same as adding the opposite. So I just made both of those the opposite sign, And now I'm going to add. So my x cubes cancel, and then my x squares, I get negative 2x squared. And I bring down my next term. Okay, 2x times what gives me negative 2x squared? Well, that's negative x. So then I multiply, I get negative 2x squared minus 3x. I'm going to change colors again. I'm going to change the sign, and now I get to add. So I add, my x squares cancel, my x's, I get negative 10x, and I bring down my minus 20. 2x times what gives me negative 10x? Minus 5. Multiply, I get negative 10x minus 15. And then don't stop the pattern now, just because we're on the last step. Change the sign, and then add. My x's cancel out. I get negative 5 for my remainder. And so it says write the expression in mixed number form. So I'm going to write minus sign 5 over 2x plus 3. And so what I am boxing in red is my answer. The 4x squared minus x minus 5, that's my quotient. And then I wrote minus 5 over 2x plus 3. So that's like my plus remainder over divisor. And that's my answer. Okay, I think we're going to need to stop here because I need to record or post the recording on Adobe Connect so that you guys can go back and rewatch it, or somebody else can. And I need to get to my next GVO. Okay, I hope that was helpful. Good luck to you guys on all your finals, and I will see my students tomorrow. All right, good night.